Good afternoon to everyone who is on the CET time zone or thereabout, and a good evening to those of you joining us from Asia Pacific time zones, and a very good morning to our North American visitors. We do appreciate you taking the time to join us today. We have a good set of information content ready for you today. And without further ado, let me introduce myself very quickly. So my name is Petteri Vainikka, and I'm the Vice President of Product Marketing at Cognite. And I have the privilege of being joined by our co-founder and CTO, Geir Engdahl, today, who will be doing a part of our product platform demo for you today. Today's webinar has a full duration of 60 minutes, wherein we will leave about 15 minutes at the end for a Q&A that we hope will be very vibrant. And again, as is customary in all webinars, you are very encouraged to post all of your questions in the questions box throughout the webinar itself, and we will address all of them at the end. This webinar is being recorded. A recording will be made available on cognite.com afterwards. And today's webinar does consist of both a presentation section as well as a live demo, followed by a Q&A at the end. And again, we do appreciate your participation and would like to thank you for joining us today once more. So very briefly on today's goal, what we are seeing in the industry around us, across our customers and across the market at large, is that proofs of concept are very common in our industries. Scaling what is a proof of concept isn't. And this is the topic of today's webinar on how to go about addressing this and moving from POC Purgatory into live production environment and at scale above all things. And we have identified 5 topics that we believe are important for us to all understand and become masters at in order for us to make this transition from a POC environment into live production at scale. The first one is, why do you need DataOps to move your digitalization program and in investments beyond the current POC or POC plus stage? Secondly, we would like to discuss a bit with you today on what DataOps really means for heavy asset industries. The term DataOps is picking up quite a lot more momentum and trending, both across the analysts, Gartner, Forrester, IDC, and others, as well as in the practitioner space. But what does it really mean when applied to heavy asset industries, as opposed to the more conventional spaces around financial services and retail, perhaps? Then thirdly, how can we supercharge industrial DataOps with contextualized data? So what is the role of contextualized data in really making industrial DataOps the superhero of your digitalization efforts? Then zooming in a bit into how a data contextualization engine actually works. So how does one actually contextualize, so fuse together all the various IT, OT, and ET data sources across a broad range of different source systems? And then last but definitely not least, how industrial DataOps with contextualization makes use case scaling an order of magnitude, or 2 or 3 even, more efficient. So this is today's agenda and the goal statement for today, and we do welcome all your questions throughout the webinar. Very briefly about Cognite, I will not spend many minutes on this, but for those who are relatively new to us, just to give you an overview of who we are. We are a company, a software as a service company born from industry with a focus deliberately to improving business operations with data. We're founded on 4 keywords: to collect or connecting, collecting, operationalizing, and scaling data. We are today slightly above 500 employees, and we are the fastest growing tech company in Scandinavia. We recently, late last year, had Axel, one of the premier venture capital companies on this planet, join us as an investor to accelerate our leadership in industrial DataOps. And we're equally a global Microsoft ISV partner for those looking at or working with Microsoft today. We're proven and deployed with a lot of key customers across different industrial verticals, cutting across shipping, pun utilities, oil and gas, as well as manufacturing. And we have a global market presence with office footprint spanning from Tokyo all the way to Austin. About Cognite, we are a world leader in the industrial data operations with IT, OT, and ET data contextualization at our core. And we're built on 3 pillars, if you will. One is our platform product offering, Cognite Data Fusion, the industrial DataOps platform. On top, and in addition to, we have 4 business applications today of our own, as well as being an active supporter and an advocate of multiple third-party partner application development frameworks, such as the Power Suite with Microsoft and OutSystems, amongst others. And our own business applications are highly packaged and software as a service provided, but they're also very customizable. And they're all built with our open source libraries of front-end components that our customers are more than encouraged to take and decompose and recompose into their own applications. And last but definitely not least, Cognite was founded in the cloud era, and we believe firmly in open standards everywhere. We support all open data sharing standards across the industry and within industries, and we are, of course, ISO certified ourselves. Then, very last slide on Cognite. So Cognite Data Fusion, our flagship platform product, is a DataOps for industry platform, specifically for what we refer to as data doers in industrial sectors. So it is everyone who works with industrial data, that is our audience. So again, without further ado, let's go into the main topic of today. So why do you need DataOps to move digitalization beyond proof of concept purgatory? Now, obviously, and why is it difficult? Well, our industrial reality is complicated. It is not easy. We don't deal with one system. We don't deal with one type of data. We don't deal with very stable data in that sense. And it is also very difficult at times to assure that the data is what we believe it to be, and that the quality or the provenance of the data is appropriate. So it's a very, very difficult environment to manage the flows of data, especially when we move into the world of advanced analytics applications and use cases, where the requirements on data flow and data flow integrity become exponentially more critical than what it is in a conventional static data dashboarding context. And again, the reality of digital that we see in industry today is that almost everyone is quite far with their proof of concepts. Many companies consider their proof of concept successful. However, if we then go and ask a more difficult question about how many have moved these proof of concepts into actual live production, the number goes drastically down. And then if we ask the ultimate question about how many have actually proofs of scale as opposed to proofs of concept, we end up with very, very few companies who are honestly at this stage yet. And this is, of course, because of our industrial reality. So we do have an OT, IT, ET data divide that we need to live with, and we need to mitigate against and ultimately diffuse entirely. There is equally an almost similar divide or disconnect between IT and data science communities, whether those are at partners or whether those are in-house. Poor data quality is a colossal issue across industry, and ascertaining and assessing data quality is an art in itself. And also data quality, as it turns out, when you scrutinize it a bit more, is actually relatively subjective to the use cases that you're looking to implement. And of course, data infrastructure is highly fractured, and all of this results in slow, expensive, and at times entirely failing transitions from POC to production, although the POC itself is considered successful and thereby could, in theory at least, be moved and should be moved into production. And just as a quick reminder of what does digitalization actually often look like, it looks like this type of a very complicated flow with multiple different stakeholders being required to implement what is oftentimes an actual quite simple data dashboarding solution. Like the flow described here is actually a relatively simple data dashboarding execution, but it does take all of these different personas, and this flow is from a customer of ours prior to them starting to work with us. So it's actually a real world diagram. So why does DataOps matter when we then think about Industry 4.0, which is of course ultimately about fully autonomous industrial operations. And where is the chasm and where are we? Now, there are three tiers to industrial digitalization, or if you can think of them as ladders as we approach Industry 4.0. The first one is to simply make information available. There's a lot of value in just visualizing existing data when we can put that data into context so it becomes meaningful. And again, this is all about users being able to really interpret information via graphs, dashboards, to make more qualified decisions based on the data they're being provided. Now, the second step, and one could argue that this is where we are today across our industrial reality in 2021, is that we're looking at being at the smart advisory system level. So we're really focusing on giving actionable advice to end users, and we're looking at doing this through enriching existing data and creating recommendation models with actionable advice. And again, simple implementations of this are, anomaly detection with machine learning, and ultimately we are still at a stage where humans will evaluate the output or the advice from these smart assistants, and a human actor will make a qualified decision based on the recommendation. And of course, the third level will be the fully automated closed loop integrations with no human interaction. And again, here we're talking about integrating models directly with selected systems to trigger automated actions. And you could argue that we are currently at this chasm stage where, because of insufficient confidence in the recommendations of many of these actionable advisors, users really, or companies really, cannot take the leap to the third level. So the argument is that we need to really focus on the data operations challenge that we have at the second step before we reach out to the third one, which of course will provide us with even more value and cost savings. But we cannot jump to level 3 before we have sufficiently addressed the foundational issues at level 2. And it really comes down to validation of all the models, providing uncertainty estimates, data quality assessments, and all of these need to be resolved before we can move to level 3. So for all of those who are looking at jumping straight into an Industry 4.0, all premier level, fully closed loop automation environment, we do recommend that you take one step backwards and really solve the actionable advisory system level first, as that will lay the groundwork to then moving to level 3. And it will actually make the level 3 transition relatively smooth, because ultimately closed loop will be about an increased level of governance requirements on the data flows themselves. So what does DataOps mean for heavy asset industries? And here, it's probably good to start with what is DataOps. We selected two very simple, straightforward definitions from two of the leading industry analyst companies, Forrester and Gartner, respectively. As Forrester puts it, DataOps is the ability to enable solutions to develop data products and to activate data for business value across all technology tiers, from infrastructure to experience. So the key is really to activate data for business value. And with Gartner going into a little bit more technical detail and depth, they define DataOps as a collaborative data management practice, one that focuses on improving the communication, integration, and automation of data flows between data managers and data consumers across an organization. And the goal of DataOps is to increase predictable data delivery, change management of data, data models, and related artifacts. And of course, DataOps uses technology such as Cognite Data Fusion to automate data delivery with the appropriate levels of security, quality, and metadata, so that one can improve the usage and value of data in a dynamic environment. And if you take these two definitions and you just focus on the keyword space, you're basically left with a very solid keyword universe at the center here, which we can all probably relate to very, very well as we are going about our days looking at how do we streamline digital operations and how do we actually move things from a POC to production. And on both two sides, you have the data managers, everyone working in the conventional realm of data wrangling, and then you have the data consumers, where arguably more and more of these data consumers are very keen to get their hands on the data pipelines themselves so that they can be more efficient in their own work. And if DataOps is about connecting data managers and data consumers, it's actually quite striking how similar this is with our IT, OT, and ET divide that we've been struggling with in industry for the past decade, if not longer. And you can actually think about DataOps very similarly connecting the data management discipline, the IT universe, with the operations technology end user needs and the needs to drive performance optimization, smart maintenance, digital worker activities on their side. So these two are very, very complementary, and you can actually very well equate data consumers with operations and data managers with IT under the umbrella of DataOps for industry. And just lastly on DataOps, to give as much context as we can to this new exciting instance, is that DataOps is of course part of the same agile and integrated family together with DevOps, for example, or machine learning, ML ops, or model ops as it's often referred to now as well. And whereas in project management and project execution, almost everything has already moved from the conventional rigid waterfall to an agile environment, in technology operations, we are increasingly moving into a similar agile and integrated environment through embracing DevOps, ML ops, and DataOps. And again, looking a bit into the future horizon, we may extend into something citizen ops or business ops, where we're actually empowering the line of business technologists as well as the line of business analysts and developers to self-service, do more and more of these conventionally application development and data wrangling, data development activities. So it is really all about enabling and providing more self-service ability to an increasingly direct end user front line. So DataOps and industrial DataOps. We've clustered the key features into two columns for you. One consists of the generic DataOps features. So these are features that you will always find bubbly surfacing in the context of data operations discussions. And these include themes such as development environment support, access control and sharing of data, obviously, versioning. So very similar to those who have worked in software development and who are very familiar with GitHub and other DevOps tools, versioning of data or models and data pipelines is very, very essential to DataOps. Orchestrating the pipeline, so pipeline orchestration, data lineage, being able to ensure that the data is what it is and having full transparency along the data lineage trace. And of course, observability. Again, very, very similar concepts as we are accustomed to hearing in the DevOps discussions. And then the specific to industry specialization features, we have data type support. So again, in generic DataOps, a lot of the data, almost all of it actually in many cases, is conventional tabular data from ERP style systems and CRM systems. However, in industry, we have a vastly different universe and spectrum of data. Most of the data that goes into especially advanced analytics use cases is time series in nature, and then we have loads of unstructured and semi-structured data, such as PNIDs, for example. We need to work with live data. So whereas in conventional data operations environment, working with CRM data, everything is batch mode in reality. In industry, everything, especially when thinking about moving to operations, so putting the emphasis on ops, not the data, is about live data, working with live data. Discovering data, so just finding data and making data, industrial data, speak the language of subject matter experts is absolutely critical. So it is not really about the conventional definition of data literacy, where you need to teach your humans to understand data. We're firmly we're convinced at Cognite that our job as technology innovators and digital leaders in our companies ultimately is to make our data speak human and not try and train our humans to be more like machines. And then other features, just to go through these very quickly, industrial equipment and process data models and templates. So again, we need to make the data fit the use cases. And the templates that we will also feature today in our demo section are really essential to scaling use cases from one to many. Model governance, time series data quality monitoring, absolutely critical in the industrial context for data operations. And last but not least, the ability to incorporate physics into the workflows as a first-class native citizen. So either it is to use physics simulators to produce synthetic data that we don't have as part of our teaching sample set for ML or DL models, or secondly, it is to produce what-if scenarios that are not available or not similarly possible with machine learning approaches. And at the very bottom, you see what is very a common sort of a best of both worlds for customers who are very advanced and very far in their data operations thinking, and they may have already built some of these DataOps capabilities into their own data platform, which oftentimes consists of public cloud-based components. And we see Cognite Data Fusion as a perfect complement to what is already in place at some progressive customers. For those who do not yet have the generic DataOps features in place, Cognite Data Fusion, of course, provides those as well, but our uniqueness and our strength lies in our industry specialization, of course. And just a very quick reminder or a teaser into today's demo. So the boxes highlighted here will be featured in today's product demo as well. Because of the timely restriction, we have left out a physics component or physics integration component from the demo, but we more than encourage you to reach out to us and learn more about hybrid AI and how Cognite Data Fusion incorporates physics into what is arguably a much more industry-fitting definition of AI as opposed to pure play machine learning or DL approaches. And then just to highlight and to surface this, DataOps platforms, Cognite Data Fusion as one, and every other platform out there as well, they're intrinsically by their DNA open. So these are not monolithic platforms which are intended to run on their own and in a standalone environment, but they're fully open, they're fully embracing the ecosystem of third-party software components that are needed to fulfill workloads. So it is really all about seamlessly integrating with third-party applications to deliver richer data work streams. Here's an example of a data work stream where Cognite Data Fusion is used as the industrial DataOps platform to basically enable this workflow of data that involves multiple data quality checks in an automated fashion, multiple stages of data pre-processing, connections to two process simulators in this particular case, and then resulting in operational instructions, dashboarding via, again, a third-party partner application, Power BI from the Azure family, in what goes into a digital twin cockpit. And the role of Cognite Data Fusion is really to act as the data fabric, the data operations fabric, the enabler of this workflow in a well-governed, continuous, and scalable manner. So how industrial DataOps is supercharged with contextualized data? So, starting, why do you need contextualized data? CRM data is easy. If we all lived in a world where we only had to worry about making customer propensity scoring models, we would probably not need to talk about data contextualization. Industrial data, however, is a whole different world. So we have multiple different data from multiple different sources that are very, very obscure to those who are not natively using those data types day to day. And we need to make those data available to more of our internal data consumers across more of our business units. And we need to connect the currently too fragmented, too siloed organizations that we have. And to make this work, we need to look at getting the data in, and this kind of a schema that you have here, or topology, is essentially what is at the core of the Cognite Data Fusion industrial DataOps platform. So we start with the source systems. By deploying connectors at the edge, we can integrate data, or we can integrate data that is already in the cloud, of course. Integration is a hybrid approach, so it can either be data replication or it can be virtualizing access to the data and leaving it at its source. Then we provide a set of data transformation services or customers are of course free to connect and keep using their existing ETL services as well. And then we move into populating the Cognite industrial knowledge graph, and the populating of this graph happens through our data contextualization services. So there are different types of possibilities. We have manual SME contextualization options in the platform. We have rules-based engine decisioning. We have custom ML-based solutions, and then we have our pre-built ML-based library as well that feeds our contextualization pipelines. And we'll elaborate and show these a little bit more in depth next. And of course, this is then used to populate the industrial knowledge graph. That is essentially a labeled property graph as a data model. And then the data is made available to data consumers through both the graphical user interface of Cognite Fusion, as well as through an API and a multitude of SDKs in popular programming languages. And the whole goal of going through this type of a data contextualization pipeline processing is to allow the data consumers to query data and discover data in a language that they understand. For example, asking a simple question through an API and SDK call, or through the GUI for that matter, what data is available for a particular pump, and to provide all the data that is related to this pump back to the data consumer, not just a particular snippet of a data, be that the time series, or be that a maintenance record, or be that an equipment sheet for that particular pump. And then, of course, what is contextualization? It is about adding meaning through relationships. It is about creating active metadata across your data to enrich your data. You can kind of think of contextualization or data contextualization as a very, very sophisticated form of metadata management, or data cataloging. That is kind of the realm where it's probably best to position data contextualization. And there are multiple different types of contextualization. Of course, entity matching is what we are all most accustomed to. So that is the art and craft of matching different resources from different source systems to each other. So it could be, for example, matching tags from a historian, such as Osisoft Pi or IP21 or some other brand, to the asset hierarchy from SAP, for example. Then we have the whole class of PNID or engineering diagram parsing, where it's all about turning or converting conventionally PDF format documents into interactive, smart, programmatically queryable information in a graph model. So here it's all about identifying the tags, identifying similar objects and object recognition, finding objects, and of course extracting patterns as well. And then the same as what is done for PNID and diagram parsing applies more broadly to document parsing. So it can be a Word document or any other document as well. And of course, then last but not least, and this is what we will focus in today's demo, is the realm of data templatization. And the goal is, of course, to make your industrial data programmatically queryable. And of course, when we achieve this, it also, as a side benefit, or you could also consider the primary benefit, it becomes human understandable. And again, here's a screenshot from Cognite Fusion of a PNID diagram that has been parsed and fully contextualized. So how does this type of a contextualization engine actually work? This is the high-level anatomy of a contextualization pipeline or an engine. We start with uncontextualized data. Initially, that uncontextualized data goes through our proprietary machine learning models that generate a set of rules that are then provided to a subject matter expert for validation in the form of a rules engine. And the rules are, of course, we cluster the data on the rules, and we provide a confidence score to every single rule that we've auto-generated. And then those rules can be tweaked or approved or rejected. And of course, that feeds back into the machine learning model, and it incrementally gets better over time. But ultimately, there's always a subject matter expert validating the process. So it is not a fully autonomous process, and it is unlikely to get there in the foreseeable future either. And the idea of also retaining the human in the loop here, of course, giving the human less and less manual heavy lifting and tedious tasks or repetitive tasks, but maintaining that integrity and that final word, that final validation step being done with a proper subject matter expert is critical to establishing solid confidence in the data. And again, different types of contextualization. The example referenced earlier is an entity matching pipeline, is what the previous slide described, is commonly used to connect tags to asset hierarchies, or connect tags to 3D diagrams, or asset hierarchies to 3D, and of course to connect all of these to the PNIDs, so the engineering diagrams as well. Another type, of course, would be PNID parsing. So these are all types of very similar. So the anatomy of the pipeline, contextualization engine pipelines, is exactly the same. They, of course, use different computer vision models and different algorithms, different ML models. And these are, of course, pre-trained by us. And last but not least, a very exciting area, especially in the context of immersive human-machine interface and rich robotics use cases in the digital twin space. Cognite is actively pioneering and investing in lots of visual data contextualization work, wherein we are using robotics and computer vision directly out at the field, at the edge, to basically automate the process of even gathering the data and contextualizing it right there and right then, so that robots, for example, can augment the data and enrich it, and thereby we can essentially move from the realm of ingesting data from different source systems, but we can actually generate the contextualized digital representation directly by observing the actual industrial reality, if we want to. And last but not least, so this contextualization, it creates trusted meaning to your data, but it only does that when it's constantly maintained. So one step is, of course, the onboarding of data. Therein we use an automated model assisted contextualization process. And that is a large work package when we contextualize the initial set of data required for particular use case portfolios. But then, and of course, there's always the third box at the bottom corner, the expert sourced mapping, so additive, corrective, use case driven contextualization, which cannot be automated, or there's simply not enough volume of data to warrant that, or to warrant training the models for that matter. And then those are done through an expert sourced additional data mapping, equally going into the same fully contextualized data image that Cognite Diffusion maintains. But very critically, the step number 2 at the center is the role of our automatic models that handle changes and changing data. So if you were to once contextualize all of your data fully, as has been the modus operandi with consultancy-led data contextualization efforts in the past, when your consultant army leaves the building, that data becomes, and that context that they created, or the links that they created, starts becoming stale relatively quickly. And this is, of course, mitigated by having an always-on SaaS approach to data contextualization as well. Of course, in addition to it running order of a couple of magnitudes faster than a human approach will or would. So, to the most interesting section and leading into the demo now, how industrial DataOps with contextualization makes use case scaling an order of magnitude or 2 more efficient. And here, we're really looking at this type of a challenge. How does one operationalize and govern at scale? And to give a very, very simple example of what this can look like in the industrial world is, let's ask ourselves, how do we scale a dashboard or a model from one valve to all valves? So how do we find similar information for all valves programmatically? How do we create a data model? What does a data model look like that can support these types of queries? Again, we need to do this programmatically for it to be scalable. And how do we govern and monitor the inputs as well as the pipelines to this solution? And again, what a single valve can easily have 10 technical documents, can have lots of time series, can have many events, and it probably is present in multiple PNIDs. And when you then multiply this across the fleet of your valves, you can easily see that it becomes a very tedious and challenging problem or need to scale if done fully manually. And of course, the solution that we are providing as Cognite with our flagship product, Cognite Diffusion, is to essentially look at use cases as data templates, or to templatize the data and the data model. So the way to move into scalable solution space is through templates. And you can kind of think about it as, and this is again a very trendy line to quote in the context of data discussion at least, manage your data as code. So for non-developers, and again, those of you who are data scientists, you're used to Jupyter Notebook environments where this is kind of a bit more conventional for you. But for non-developers, having a GUI in a product that allows them to do what you can more conveniently do with the data science notebook is quite striking when you put it to life, or when you give it to the users and allow them to actually work with it. And of course, you need, a process to define and manage tag sensor updates, as well as additions of equipment instances. You need templatized calculations with defined input parameters and attributes. And all of these can be pre-built into the template and need to be pre-built in the template, so that we're pushing as much of the complexity of the actual application scaling onto the data platform level, leaving the actual application experience to be a very simple visualization exercise. And of course, we need full transparency and visibility and lineage of all the input data, which again comes through very nicely in the Cognite templates, where you can directly interrogate and observe the data that is either automatically suggested or is human applied onto the template. And of course, then we are also embedding natively all types of health checks for missing data and bad data quality, and surfacing those metrics as well. And in this templating function, we're also allowing for use case specific, so subjective data quality monitoring, with the intent of debottlenecking parallel use cases in a digitalization program from preventing other use case to proceed, because some of the data has not yet been centrally approved for use. So again, if you really only want to do a reporting dashboard, you don't necessarily want to limit yourself to waiting until all the data is centrally certified as perfect, which arguably probably will never be in the time series realm at least. Whereas again, if you're building something more advanced for predictive maintenance, for example, then you do need substantively higher levels of confidence in the data quality. So again, you can look and approach the data quality dimension also subjectively at the use case level through the templating function in Cognite Data Fusion. And of course, by pushing the governance of data and the scaling through the templates features to happen at the data level, you end up in a world where application development is much more rapid, and you can pursue much more diverse application development opportunities in parallel. So I thought I would put in a bonus section, because we get this question so many times from our customers, that I wanted to share it with you today. And it is this question. So, okay, we have our own data platform project ongoing. How does this align with Cognite Data Fusion? And it actually aligns really, really well. And in the interest of time, so we can move into the demo, you can, of course, obtain the materials in the live recording as well later for higher fidelity examination. But with your own data platform, you probably are using public cloud services from Azure or some other public cloud service of your choice, or for multiple. And with lots of time, you can, of course, build anything using public cloud services. But with Cognite Data Fusion, we're specifically focusing on a couple of key capabilities that are hard to come across in a public cloud context, at least in the foreseeable future. And one is a proper industrial knowledge graph. The other one is the ability to really contextualize all of the IT, OT, ET data together, as well as to really understand the industrial data hubs as first-class citizens, and to use industrial domain language in the product so that domain experts can express their data request in their own language, as opposed to needing to learn the language of a conventional horizontal data warehouse or data lake. And of course, the ability to scale use cases in a well-governed way through templatizing. To put it short, with Cognite Data Fusion, you put industrial data in and you get insights and application scaling out, which is quite a different proposition to a do-it-yourself data platform initiative. And of course, Cognite Data Fusion is built on Azure, and we are built as a focused and modular industrial data platform. And we can also be fully embedded and encapsulated into your data platform, wherein we only provide the complementary parts to your data platform initiative. So with this detour excursion, it is finally demo time.
So my name is Geir Engdahl. I am the CTO of Cognite. So what you're looking at right now is the main user interface for Cognite Data Fusion. I will take you through scaling a particular use case, and this use case is about condensate banking in gas wells. You don't need to know what that is. It's a phenomenon that can happen in gas producer wells where they lose some of their productivity. It's something that we want to detect early in our fleet of wells so that we can mitigate it. So this Cognite Data Fusion interface is, there are kind of four main parts here. One is the ingestion and integration of data. On the left-hand side here, you have contextualization, where we're kind of populating all the edges in this graph data model. And we have the explore and build section, which we'll focus on here. And there's also the manage and configure, where you set up access and slice and dice access, ensure lineage and data quality rules, etc. So what we're going to do first is we're going to have to find these gas wells and the associated time series that we're going to do detection on. So here you can navigate the data either hierarchically, or you can do just a free text search. So I'm interested in reservoir pressures, for instance, and I want time series. So you can see there are all these different kinds of data types supported, but this is what I'm interested in. So I can preview quite easily these time series, and I found a few here that are interesting to me. So my next step as a data scientist here is probably to start to experiment with this data and build my model, which I'll do in a Jupyter notebook. And once I'm happy, actually I can do that in the context of Cognite Data Fusion as well, as there is this Jupyter notebook section, which we'll look at later. But once I'm happy with that model, I need to scale it to all my wells, and that's where templates comes in. So with templates, I have the opportunity to essentially build my own data model. So here I can say, okay, I want to have a new template. It's going to be called gas well. This is the ID that I'll use to refer to it. And here are the properties that I expect each gas well to have. So I want the bottom hole pressure, I want the gas flow rate, productivity index, etc. And I can set what kind of data type this is. So for all of these, I expect time series, because this is live data. It's coming from some sort of historian or control system, and it continuously flows in. So time series is the appropriate type here. So when I've defined this model, I add my wells here, and I can use a categorization script or some other automated way of doing that. But then I'm essentially left with this problem of filling in this matrix of properties, because how is the system to know what is the bottom hole pressure of well 001? So this is a supervised learning challenge. And as I fill in some of these, the system will learn the patterns so that it comes up with suggestions here. So it's actually found 10 more suggestions for these properties for me based on what I already filled in. So I can go in and I can review these suggestions. I can say, okay, this looks like it is the bottom hole pressure of well 11. So I can confirm that. And I can select all of these and essentially fill in my entire matrix. This is based on the graph, the industrial knowledge graph created. So here I have my matrix, and now this becomes available as a query language in Jupyter notebooks, in dashboards, etc. So this data model that I defined is now available to me as a data scientist. So don't worry about this calculation here. This is a very simple physics calculation and some denoising. But this is what's important. This is how I'm getting my data for this into this calculation. So here I'm looking at this template. I'm getting the list of gas wells. I'm getting for each well the name, the bottom hole pressure, the reservoir pressure, gas flow rate, etc., with the identifiers that I specified in my template. And now I can do my calculation. And that provides me with a very easy way of just iterating over all of these wells and calculating the health of each well. And having done that, I can show this health in a dashboard. So here's a Grafana. It's a very standard, very popular tool for displaying dashboard, making dashboards. So here I'll take this drift indicator that my script just calculated for all of these wells, and voila, now it's doing this for all of my wells. If I need to add another well, I do this here, and it will update in all my scripts, in all my dashboards, etc. Of course, now I ran this calculation once here, but I want it to run continuously. So what I can do is I can use the Cognite Data Fusion SDK here and deploy this function that's doing my my calculation, my anomaly detection here, to Cognite Data Fusion. And now that is deployed as a Cognite function. So I can find this here under Cognite functions, and on the second page here, you see this gas well productivity index calculation with its status of deploying. And here I can configure schedules so that keeps on running. And also, I need to be sure that the time series that I'm basing these calculations on have the right data quality. So I go to the data quality monitoring part, and here I can set up rules for these time series that are associated with this template. So I can say, you know, the data has to be fresh. It must not have been flatlined. It needs to be between these values, etc. And I can set up what will happen if these constraints are not met. And the output of these constraints is that's also available programmatically. So I can see kind of in what intervals the data quality was not matching what I needed. And I can even embed that in my dashboard. So an operator getting advice from this will see at any point in time whether the input data for my calculation has good data quality. So that concludes the very brief demo today. With that, I'll hand it back to Petteri.
So just to wrap up very, very quickly, and for those of you who would like a more in-depth demo, you're more than welcome to reach out to us, and we can set up a full hour or two with an end-to-end, top-to-bottom product tutorial for you. Again, today's session has really been about, you know, how do we as an industry, how do we collectively move away from the POC purgatory? How do we find ourselves in a place where scaling use cases can actually take place and is taking place actively, as opposed to us looking at successful POCs, but inability to really get our CFO to confirm that they're producing value. So today we've discussed with you why you need DataOps to move your digitalization beyond the POC purgatory. We've discussed what DataOps means for heavy asset industries and what specialization or DataOps specialization you might want to look out for when addressing or looking into DataOps for your particular organization. We've discussed how industrial DataOps is supercharged with contextualized data, and arguably everything that Guide also showed to you in the demo would not be possible if the data wasn't already fully contextualized before and in advance. So it would not be possible to SME or through a subject matter expert lens validate that the data is correct, neither would we actually be able to populate those templates in an automated fashion. We've discussed very briefly about how a data contextualization engine actually works, and we're again more than happy to go into more depth on all of these with you at another time in a one-on-one context. And of course, we demo to you how industrial DataOps with contextualization makes use case scaling significantly more efficient. And again, in our small demo snippet today, we only had a handful of wells, but of course, those of you in the audience in the oil and gas vertical very well and know that there are many wells, hundreds and thousands in some cases. So the challenge is not to populate a 6x5 matrix, but the challenge is populating a substantially different order of magnitude matrix. So with this, I would like to thank you all for having taken the time to listen to us today. And we do understand that time is precious, and we do understand that you are all probably bombarded with lots of online content these days. So we do genuinely appreciate your time. We would like to give you a slight preview of other upcoming webinar content from Cognite, as well as point you to an article on our blog that addresses today's topic in a somewhat more, or even somewhat more technical nature, specifically on how to scale use cases with data contextualization. So with this backdrop, I would like to open the floor to questions from the audience. And of course, we will start with the questions that we have received so far. And let's see which one of us, should it be me or Geir, taking the questions. So let me probably, I'll put this first one to you, Geir, just because I can't put you on the spot here and now. The question is, can you give a concrete example of a customer you are working with in terms of what scale means to them? So when you talk about scaling, what do you mean with the word scale?
Yeah, so that's a very good question. So one of our customers, NOC, where we use this technology to scale from one oil platform to a set of 34 oil platforms in one of the largest oil fields in the world, offshore fields. So that's hundreds or even thousands of wells. So that's kind of the scale that we are talking about. We have several customers that are scaling these sorts of solutions to on the order of thousands of assets.
Very good. Let me I'll actually start putting all of these to you, guys, just to for the sake of my own simplicity. And if there are some you'd like to boomerang back to me, please feel free to do so. There's a question from the audience about AspenTech HYSYS cited on one of our slides, along with the process description. How does that interact with Cognite Data Fusion?
Well, so the very simple overview of that is that HYSYS performs some calculations, based on data that is living in Cognite Data Fusion, and writes the insights, the computed values back. So I'm not that familiar with the exact use case where we used HYSYS, but that's something that we could dive into in a follow-up, and we can give you the exact details for that particular integration, whether it's push or pull based.
Thank you. Another question, continuing on the topic of combining physics simulations with machine learning. Can you please talk about the use case that combines physics-driven model with a data-driven model for asset management? For example, identify transformer failure. I'm not sure if you can take this on the call now, or if this is equally a question that we would love to have a deep dive with one of our principal data scientists or experts on the topic of hybrid AI.
Yeah, when it comes to the transformer failure, I'm not that familiar again with that particular use case. I could talk about one use case where we did a dynamic max flow calculation for a separator that's based on a physics model, and augmented with machine learning to make the calculation faster. So there we essentially used model calculations as input to build a physics model runs to build input to a simpler model, which can be executed very fast on dynamically changing conditions and produce essentially a maximum capacity for a piece of equipment that's based on actual conditions and not kind of conservatively set worst case estimates, thereby increasing production in the entire facility by a few percent.
Very good. Next question on comment from the audience. This is great, but it's more advanced than most users and users in my company are ready for. So can you talk about the characteristics of unsuccessful companies attempting to implement, and as well as characteristics of successful companies that are implementing cognitive diffusion?
I think this one is more for you, Petteri. You want to answer that?
Thanks for throwing it back at me. Yes, so we have the privilege at Cognite to work with quite a lot of different companies, both across geographies as well as verticals, as well as digital maturity phases, if you will. And it sounds very mundane, and everyone always points to this, but leadership and culture do play a big role. But if we then look at like the characteristics of companies that are most successful, it is those who really focus on the hard problems first, as opposed to just plainly focusing on getting something flashy and cool for a presentation at a conference. So the characteristics of those who are successful at scaling and getting to value are those who are very methodological about what is value and how to measure it, and those who really seek to understand and address the difficult questions, as opposed to taking the easy route and just focusing on what can they do very quickly that would allow them to have a nice case study at a conference. That's kind of from my perspective, at least, and I do spend quite a lot of time with our customers all over, and that is my takeaway from it. Again, if you would like to have a more in-depth session on these characteristics, I'm sure we can actually set that up as well with our customer success teams who have done more research into this. So my take on it, or my response now, is somewhat anecdotal from the customers that I have personally been engaging with. Then another question from the audience. Scaling up from one to all is the key challenge. Any tips or limitations for using CDF to scale real-time applications? This one goes to you guys.
Yeah, so it depends on your definition of real-time first, because in the OT domain, I would not use CDF to kind of do surge protection in compressors, where you have to respond in fractions of milliseconds, because CDF is a cloud-based system, so you need to get your data from kind of the actual equipment to the cloud, do some kind of processing, and back. And as Petteri was saying earlier, there's really in most all cases, there's a human in the loop. So it's an open loop advisory function. So it's kind of action can only be taken on the time scale of tens of seconds or minutes. That's kind of the closest to real time in that kind of environment that you get. And if that's the case, then the extra milliseconds that the light uses to reach the cloud and do something there doesn't really matter that much. Of course, you also want stable connectivity, but that too is improving worldwide with better connectivity. Yeah. So, but other than that, Cognite Data Fusion will index, process the time series data and make it queryable within a few, like 99% of the time series data is queryable with very advanced queries within 200 milliseconds of it reaching Cognite Data Fusion. So that's to give you an idea of the real-time performance. And that's for tens of millions of data points streaming in per second. It's going to have really large volumes of that too.
Another question from the audience, and because we're running out of our allocated time today, I do have to apologize, and we promised to get back to everyone with questions one-on-one that we could not take today on the call. But the final question to you guys: what happens when systems like Siemens or SCADA systems in general are not configured optimally, and in that case, you might miss some key data inputs?
Yes, that's true. And that's one of the side effects of actually surfacing this data in the first place. You figure out how messy it is. And so our customers have had to iterate on the configurations of their SCADA systems to actually start to record the important data, because a lot of data does not flow into the historians even. That is important. So it's an iterative process, but it does help to make that data visible in its right context, maybe plotted on top of a 3D model so people can find it and see if it is what is expected. And we had great success with a field worker application where the people on site can view all this data on their phone. And of course, they are very familiar with the system, so they notice when stuff is missing.
Very good. We are a couple of minutes over subscribed on our time allocation today. Once again, thank you everyone in the audience, and we do promise to get back to everyone with questions, as well as those who have already requested a follow-up. So thank you again to everyone on my behalf. Thank you on the behalf of Cognite at large, and we do wish to see you again shortly. Thank you.